My name is Sebindo Gibson Alassasli. I'm going to explain about the abstracts of our report. In the study or report, the research is given a big title which is broadcasting. Broadcasting is the distribution of audio, video, or web signal to a number recipient, which is listener and viewer, that belong to a large group. This group may be public in general or a relatively large audience within the public. Broadcasting may involve auditory information only, as in radio, or visual or combination, as in television. As technology has advanced, it is the same for the forms of broadcasting. Historically, the term broadcasting usually has referred to a radio and television industry. Broadcasting was previously synonymous with over-the-air broadcast, where the radio frequency spectrum is limited and thus regulated. The concept and ability of broadcasting to concept the same information, whether announcement of current event, educational material, or simply entertainment to a worldwide audience simultaneously, is a great advance in allowing humankind to overcome long-standing barriers. Therefore, the topic will be covered in more depth in this report is about digital audio broadcasting. Introduction. Digital audio broadcasting, which is we know as DAB, is a type of radio network that sends digital signal instead of analog ones. This allows digital audio broadcasting network to have stronger signal strength and higher quality. DAB also permits text to be sent with radio content, allowing listener to read about what they are listening to. Digital audio broadcasting (DAB) was developed toward the end of the 1980s. The first network was installed in the 1990s. Current analog FM radio broadcasting system in VHF band cannot satisfy demand of future, such as excellent sound quality, large number of stations and small portable receiver, and no quality impairment due to multi-path propagation. Digital audio technology has set technical quality standards which are far beyond those available to radio broadcasting transmitted over the analog. Digital audio broadcasting (DAB) is the most fundamental advancement in radio technology since the introduction of FM stereo radio.
Okay, so I'm Intan Rashaira and I will continue to present the literature review. DAB or Digital Audio Broadcasting is a digital broadcasting system that developed in the 1990s by the Eureka 147 project and is prompted by the European Broadcasting Union. And DAB also was recommended as a terrestrial and satellite broadcasting system and include a standardization process with European Telecommunication Standards Institute. Why we need DAB is to allow broadcasters to transmit AM and FM analog signals using their current radio spectrum with other high-quality digital signals. Other than that, as the DAB reception quality degrades quickly, so it's become more resistant to noise and multipass fading. There are some advantages of DAB includes providing high quality sound as it sends information at faster wavelength. Second, DAB has a high robustness multipass reception and then low transmitting power. So for now, we move on to the methodology. So this figure shows how the DAB system works. Mainly, the system consists of two main areas which are audio digital encoding and modulation system and compression system. It starts from the source and then energy dispersal scramble is to distribute the transmitted signals energy properly. After that, the scrambled bit stream is put through to convolutional encoded FEC and then the multiplexer's output is added with service information in the fast information channel in order to form the DAB frame. Then perform a shifted pi/4 differential QPSK modulation. The output of the FIC, MSC, and PRS then generated by the block name synchronization symbol generated is the pass to the OFDM signal generator. Besides, another essential component is modulation system, where it is a type of speed spectrum and known as COFDM, which aims to provide robustness. Finally, the null symbol completes the DAB frame structure. So this figure 2 shown a structure signal frame to help DAB work with efficient receiver synchronization. So that's all from me. Thank you.
Hello, my name is Arindra and Lucky Sarana and my matrix number is B0820010040. So I'm going to continue the results and discussion part for assignment. So in this part, we are actually comparing digital audio broadcasting with the FM radio. So a radio is actually a device that transmits electrical energy which carries sound messages from a transmitter to a receiver. So this electrical energy is actually being transmitted in a form of a carrier signal, and this carrier signal is known to undergo a process which is called the modulation, in which the carrier signal would undergo modulation in its properties, which is periodic and is varied with the help of the message signal. So there's two types of modulation a carrier signal can undergo. Firstly, it is known as the amplitude modulation, where the amplitude of the carrier signal is modulated by the message signal. The second technique is known as the frequency modulation, now in which the carrier signal's frequency is being modulated by the emissive signal. The FM and the AM radios are actually signals that can be received by an analog radio. Meanwhile, if you take a look at the digital side of the radio history, digital radio is actually the transmission and reception of sound waves processed in the patterns of binary digits, which is 1 and 0. Now, this binary data, this pattern, is actually encoded and transmitted from a radio station where a receiver receives the signal and then it decodes the data and processes it into a sound message that we can hear from the radio. Now, since we're actually going to talk about comparing the digital audio broadcasting and also the FM radio, we want to compare the performances of both these radios. Now, we're going to talk in terms of the sound quality that DAB and the FM radios produces. Now, theoretically, DAB can produce better sound quality than the FM radio, but when it comes to practical application, FM radio offers a better sound quality. Now, this is because the digital radio broadcasts, they actually compress their broadcasting. Their broadcasting range is actually being compressed to allow several other radio stations to broadcast as well. And they use the same frequency range. So this makes the sound quality that is being transmitted by the radio stations to be compressed, and it produces a low quality audio to the listeners that are using the radio. Now, this quality of a digitalized audio is actually determined by its bit rate, which is actually measured by kilobits per second. Now, diving deeper into how the audio format of DAB and FM radios. DAB uses the MP2 audio format, which is quite old if we take a consider to the current audio formats that's being released. But then there was a system upgrade. There's an upgrade in the system which allowed the wave to DAB Plus to be introduced to the audio to the radio stations. Now, this DAB Plus uses the AAC Plus audio format, which actually offers better and enhanced video audio than the DAB, the regular DAB. Now, if you take a look at the FM, now FM radio is an analog radio, so it doesn't have a bit rate. But if a signal from an FM radio is being translated into a digital signal, it would be equivalent to a MP3 file. So which makes the audio of FM radio to be better than the digital audio broadcasting's audio format. Now, another highlight about the sound quality here for DAB and also the FM radio is the lag that is being produced. Now, DAB, since it's digitalized radio, it uses computer chips to process the sound. So when there's interference or there's a distortion in the signal, the computer chips would work on the delays, and sorry, it works on this interference and they try to fix this. So when this is happening, there's a delay, there's a lag in the sound playback. So which makes the DAB radio to be more lagged, and it reaches the radio slower than that of an FM radio. So the next features that we are going to compare the two radio stations with the choices of radio stations that both these radio stations offer. Now, DAB, they actually can offer higher spectral efficiency, which actually is measured in programs per megahertz, and also it can be measured in terms of programs per transmitter site. Now, so when we compare DAB and FM radio, DAB offers more number of stations to its listeners. And just now we talked about DAB Plus, and this makes the radio stations to use more efficient codec, which allows a lower bit rate per channel with only a small amount of loss in audio quality. So if the radio stations transmit the signals in mono, the bit rate can be reduced comparing to a stereo broadcast, which improves the efficiency of the audio. And now we are actually going to talk about the advantages of digital audio broadcasting. Now, firstly, we want to talk about the improved features of users. Improved features for the users. So since digital audio broadcasting is a digitalized radio, it actually can scan over the frequency range, listing all the stations from a single list from the user to select from. So it makes the users to navigate and to find their favorite radio station to be selected easily without them scouring over the whole list. And also, DAB provides a metadata along with the audio stream. So with the metadata, the users can view visual informations such as text, graphics, the name and the logo of the radio station, which helps the users a lot in selecting the radio station. And then talking about another feature of the DAB is the radio text feature from the radio station, which actually allows the station to provide real-time information which occurs in real time. Example, traffic updates. And these updates that the users receive from the radio stations are actually in 128 character length. So this radio text is actually to help users to know and to understand their surroundings while listening to the radio. And there's another feature in the DAB transmission which is called the time of day. Now this actually functions as an internal clock automation setting. So this what it does is that it functions to automatically correct the internal clock of a device when traveling between two different time zones. Okay. Now the second advantage that DAB possesses here is the reception quality. Now DAB integrates features to reduce the negative consequences of multipath fading and also the signal noise. So this is the plus side of DAB, but if you compare this to the analog systems like FM radios, they don't have this feature. They don't have this um, technology where they can reduce the consequences of multipath fading and also the noises that's being produced. So with this, the digital, I mean the sound from the DAB radio stations would not have the hissing sounds that we hear from the FM radio. Okay, so this is a good thing because while listening to the radio, there will be no distortions and there will be no interruptions for the users when they're listening to their favorite radio station channels. Now, thirdly, the third advantage of the digital audio broadcasting is that it has a variable bandwidth. Now, programs like mono radio talks, news, and also weather channels, they need only a less bandwidth than the typical radio stations that we hear. So this allows DAB to carry these programs at a lower bit rate, and at the same time, this allows more bandwidth to be available to be allocated to other programs. So now we are moving on to the disadvantage of digital audio broadcasting. So as we talked about the signal delay just now for the DAB, so that's a very big disadvantage for the DAB when it's compared to the FM radio. So the single frequency network, it requires the transmitters in a network to broadcast the same signal at the same time. So to achieve this synchronization, in order for all the radio stations to broadcast their signal at the same time, the broadcasters in the radio stations have um, must have these counters to differentiate the propagation time cost, and then they have to overcome this by applying a delay in the signal. So this delay is actually inserted at the transmitter, and it's actually usually based on the timestamp generated at the multiplexer of the radio station. So these delays in the audio encoder and also the receiver due to the digital processing also add up to the delay received by the users in the radios. And the second disadvantage of DAB is the transmission cost. Now, DAB can provide savings for network of some stations because the DAB was originally developed with several channels to transmit from multiple sites. But for individual stations, like local stations, which operate their own FM transmitters on their own buildings, they need a higher cost. The transmission cost is higher there. So therefore, operating a DAB transmitter for a single station does not use the spectrum efficiently. Now, the third disadvantage that DAB possesses is the power requirement. Now, since DAB requires digital signal processing, it needs these techniques to convert the digitalized signal to be converted to the analog audio message to the users to listen. So the hardware setup is more complex than that of an FM FM radio. So this conversion also needs a high power compared to the conversion power of a FM radio. So that is all. Thank you very much.
Conclusion. In the end, by the using or development of DAB, the listener or user will be able to obtain a better quality of audio. Multipath interference, which is the main problem of analog FM, can be reduced or will be able to be avoided. But there will be some of the part that can be avoided, such as reception quality. The quality may be poor even for the place within the coverage area. Another problem will be the signal delay. This is due to digital processing adding to the overall delay perceived by the listener. However, DAB will be the sound of future. We researchers is believe that it is still in the part of growth and development. It has a lot of potential that can be explored and developed. DAB is going to replace the present method even though it will be taking some time. Thank you.